Each of the following problems describes a situation which can be modeled by a periodic function. For each, give two possible equations for the periodic function. One of your equations should use sine and the other cosine. It may help to look back at your notes from periodic functions part 1 from the last class. Answers follow. 1. The temperature of a chemical reaction oscillates between a low of 30 degrees Celsius and a high of 110 degrees Celsius. The temperature is at its highest point now and completes one cycle over a 5-hour period. Model the temperature T as a function of the time from now in hours over a 10-year period. So let's first start with a graph. So it says that the low is 30 and the high is 110. And it's at its highest point right now. So we start up here, and then it takes 5 hours to do one cycle. So 5 is here, and by the time we get to 5, we have gone down to our minimum and then back up to the max. And we wanted to see 2 cycles here. So it will dip down and then come back up after 10 hours. Okay, so let's first start identifying the different pieces to this puzzle. So we know that the period is 5, which means that the b is 2 pi over that period, which is 2 pi over 5. And next thing is the midline, which is the middle. So all we have to do is average the high and the low. So we get 65, no, we get 70, which is our value of k when we write our equation. And next is the amplitude. To get from 70 up to the top is 40, or 70 down to the bottom is also 40. So the amplitude is 40. And the horizontal shift we'll talk about, but let's first think of this, is it more naturally a sine or a cosine? Well, where does it start? Does it start at the top, middle, or bottom? So this one starts at the top, so to me it feels like it's naturally a cosine. So we'll put our amplitude first, 40 cosine, the period was 2 pi over 5, times, now normally there's t and then like the horizontal shift, we'll leave that blank, and then plus the k value in the midline is 70. But in this case, it is just naturally a cosine, and it doesn't need to shift horizontally at all. So it's really just 2 pi over 5 times t. So we can get rid of all this extra stuff here and just make it cosine of 2 pi over 5 t plus the middle. Okay, but if we were insisting on trying to use a sine graph as well, then we'd have to pick a place where it doesn't start at the middle, but rather doesn't start at the top or bottom, but rather starts at the middle. So you could picture this guy and then have it going down, or this guy and have it going up. You might try both. We'll just try the first one. So starting here in the middle and on its way down, that makes it not just a sine graph, but actually negative sine. And then we'll copy everything else from up above. So the 40 is still the amplitude, 2 pi over 5 times t. This time there is a horizontal shift, so we'll leave a blank space there, plus the k, 70. So in this case, again, you got to think about, well, where does negative sine normally start? It normally starts in the middle and on its way down. So the question is, how far do we have to shift it to get to there? Well, this is a shift to the right, and it looks like, let's see, is that at the middle? No, my diagram isn't very accurate here. The middle is actually there, right? That's 2.5 right there. This is actually the next middle, which is 1.25. Remember how we oftentimes will cut the graph into quarters, each of the quadrants, right? So the period is 5, so cut that into fourths, and this middle point is at 1.25. So that's the horizontal shift, and it's to the right from where it normally is, so t minus 1.25. So we won't do it here, but you might pause the video now and graph the green and the purple equations and make sure they both match the reality, the thing that we've drawn by hand. 2, the amount of daylight varies over the course of the year. The summer solstice, which occurs on June 21st, the 172nd day of this year, is the longest day of the year. In Greenfield, there will be 15 hours and 18 minutes of daylight. The winter solstice, which occurs on December 21st, the 355th day of this year, is the shortest day. In Greenfield, there will be 9 hours and 5 minutes of daylight. Model the length of the day in hours, d, as a function of the time t in days, where January 1st corresponds to t equals 1, January 2nd corresponds to t equals 2, etc. So we'll begin again with a picture. So we know that at the top, we've got 15 hours and 18 minutes of daylight. So let's convert that 18 minutes into hours. So let's see here, we've got 18 divided by 60. So that's 15.3 hours. That's at the top. And then at a minimum, it's 9 hours and 5 minutes. So if we do 5/60ths, we get 0.08 and change. So at our minimum, we're at 9.08 and change. And then tell us when these things happen. So the max happens at day 172, up there at the top. Minimum happens in late December at day 355, down there at the bottom. And so we can connect the dots, and we'll see that this isn't a complete cycle, but rather that's only half. So it keeps going this way. And when do we hit that minimum? Let's see. Must be December of the previous year, which actually means that we don't quite get to the minimum on January 1st, but maybe a few days before that, and then it turns around again. So let's go ahead and I'll move this over just a little bit. So there's your 355. So we'll start writing down the pieces here. We know that that period is a full year, and this is in days, so 365 days, which means that the b is 2 pi over that number. Okay, next thing is the midline. We'll average the high and the low. Okay, and I'm going to want to use that number right there instead of rounding it. So, so let's actually type this in the right way. So 15.3 plus 9 plus 5/60ths. And then we can divide that by 2. So 12.19 roughly. So this is the D equation, but we're calling it K in general. Okay, so we've got those two pieces. The horizontal shift we can deal with last. Amplitude is the only other thing we'll need to handle right now. So it's the A value, and it's how far to get from this 12.19 up to the top. So if we did 15.3 minus that answer, $3.108, so about 3.11. Okay, so the last piece of this puzzle is to decide if it's naturally a sine or a cosine. Guess what? It's neither one, or it's both. Neither one of them seems to have the edge at this moment because where this graph starts on the vertical axis, the d-axis in this problem, it's not starting at the top, it's not starting at the bottom, and it's not starting in the middle. It's starting at some like random point, which is about 10 days from the bottom. So this is the whole idea, is that we can use the power of shifting to make it so that it makes no difference at all where this thing starts. So you can pick your favorite natural starting point anywhere on this graph, be it a top, middle, or bottom, and we should be totally fine. So what I'm going to do is choose the top point right here, because that's given to us at 172. So if we use that 172 as our start, then we can fill in our pieces here. Y equals, so the amplitude we said was 3.11. So if it starts at the top up there, then that's a cosine. B is 2 pi over 365. T, and then the horizontal shift we'll talk about, and then plus the middle, we said was 12.19. So if that's starting at the top like a cosine does, then normally cosine would start here on the y-axis. So how far do we have to shift this one? Well, we got to shift it to the right, exactly 172 days. And that's why I picked that point, because it's already got a label on it. So we can use 172 to the right, just like that. Okay, now to pick another equation that matches this graph, well, the easiest thing to do would be to pick this point right here. Is that a top, middle, or bottom? That's a bottom, so that's a negative cosine. And you can just shift it to the right by 355. So just make this a negative, make this 355, and you've got another perfectly good equation that lands exactly on that graph. The problem here is that the instructions are going to force us to use a sine graph. Instead, one sine and one cosine. So we need a new point. And it seems like your new point is either going to be the middle here or the middle here. I'm actually a little bit reluctant to try to figure out what the middle is here. It's a little bit tricky because it goes like 10 days over. But easier would be to find this middle, because I firmly believe that middle is going to be halfway between the 172 and the 355. So the question mark, which is the middle, is just going to be 172 plus 355 divided by 2. So that turns out to be 263.5. And so that means we can just write our equation now for a sine graph. 3.11 sine 2 pi over 365. T minus, we're shifting now 263.5 days to the right, plus the 12.19. The only other piece here is to decide if it's really sine or if it's negative sine. If this is my starting point, then we are in the middle and on our way down, which means we are negative sine, which means a negative 3.11. Again, there are lots of different correct answers to these problems. It's okay if you don't get exactly the ones that are in the answer key, but you could certainly check any graph that any equation you come up with by graphing on the calculator and comparing to what you know it should look like.